Good day everyone, I'm Teacher Direct and welcome to Mathematics 10.
Today, we will be discussing all about arithmetic sequence. But before that, let us first define what is a sequence. A sequence is a function whose domain is a finite set or infinite set. When we say finite, the set contains a specific number of elements, while infinite has an unlimited number of elements. Now, when we say arithmetic sequence, it is a sequence where every term after the first is obtained by adding a constant called the common difference. To further explain the definition into simpler term, let us have this example. The set shown in the presentation is an example of a finite set with 5 elements, namely 3, 6, 9, 12, and 15. Furthermore, 3 is considered to be the first term denoted by a sub 1, followed by 6 denoted by a sub 2, 9 denoted by a sub 3, and 12 denoted by a sub 4. The last term, which is 15, denoted by a sub 5. Now, let's try to look at the difference between two consecutive terms in the set. As you can observe, all of them has a difference of 3. This 3 is what we call the common difference. Now let us try to solve problems involving arithmetic sequence. Problem number 1. In a given set of 4 elements, where 5 is the first element, followed by an unknown, then 13, then the last term 17. The question is, how do you find the second term? I know it is easy to give the answer for the unknown, and I know you already know what the answer is, but for the sake of discussion, I will try to explain what we do to solve it. First, we need to find the common difference. And we do that by looking for two consecutive terms and find their difference. We have 13 and 17. And by doing this, we now have the common difference, which is 4. Then we add the common difference to the number before the unknown, which is 5. That is 5 plus 4. Therefore, the second term is 9. Now, if we are going to check the difference between 9 and 13, we will also get the answer 4, which should make our answer correct. Now let's proceed to problem number 2. Now we have an example of an infinite set with a common difference of 2. Now the question is, how will you find the 45th term? Solving this manually would take ages. To solve this, we would need to use the arithmetic sequence formula. That is, a sub n is equal to a sub 1 plus quantity n minus 1 multiplied to d, where a sub n is the unknown term, a sub 1 is the first term of the sequence, n is the position of the unknown term, and d is the common difference. We will use this formula to solve the problem. And how do we do that? First, we will identify the known terms which would be used to solve the problem. We have a sub 1 is equal to 2, d is equal to 2, position of the unknown term is equal to 45. Using the formula, we substitute the value of the known terms, and by simplifying, we have a sub 45 is equal to 90. Therefore, the value of the 45th term is 90. Now let's proceed to problem number 3. How many terms are in the arithmetic sequence whose first term is 9, common difference is 7, and the last term is 212? From the given, we have a sub 1 is equal to 9, d is equal to 7, and a sub n is equal to 212. The question is asking how many terms are in the arithmetic sequence. And we will be able to find the answer if we will know what is the position of the last term. So we use the formula for the arithmetic sequence, and we will solve for the position of the last term. We substitute the value of the known terms. We have 212 is equal to 9 plus quantity n minus 1 multiplied by 7. Next, we multiply 7 to quantity n minus 1. We have 212 is equal to 9 plus 7n minus 7. By arrangement, we have 212 is equal to 9 minus 7 plus 7n. Then we simplify to have 212 is equal to 2 plus 7n. We need to single out n, so we apply addition property of equality by adding 2 to both sides. Then we simplify to have 210 is equal to 7. Then we apply division property of equality by dividing 7 to both sides. And we have 30 is equal to n. And by symmetric property, we have n is equal to 30. Therefore, there are 30 terms in the arithmetic sequence. Problem number 4. This problem asked for the value of the common difference given the first term and the value of the 30th term. By using the formula of the arithmetic sequence, we are going to find the value of the common difference by solving the 30th term. By substitution, we have 427 is equal to 21 plus 29d. By APA, we have 427 plus negative 21 is equal to 21 plus negative 21 plus 29d. We simplify to have 406 is equal to 29d. And by division property of equality, we have 406 divided by 29 is equal to 29d divided by 29. We simplify to have 14 is equal to d, and by applying the symmetric property, we have d is equal to 14. Therefore, the value of the common difference is equal to 14.